All right, so we are going to spend the next 3 lessons focused on ways to represent a set of data. Our first two are going to be more for what's called quantitative data. I'm just gonna write that up here. You don't have to write it down. So that's just gonna really help us determine like how the data varies from value to value. And when we're not trying to categorize things, we're trying to represent things numerically. So quantitative. All right, and so the one is called a box and whisker plot. And so a box and whisker plot is something that shows the variability of a data set along a number line using the least value, the greatest value, and the quartiles of the data. And so that is called, these 5 things together make up what's called the 5-number summary. And we'll talk about some of those key values in the set of data. Okay, and so if you look at this box and whisker plot, we've got these 2 boxes right here, and then we've got these 2 whiskers. And so each piece is not necessarily always going to be equal in length, and that is one of the most important things to understand about a box and whisker plot. Since we're breaking it up into quartiles, right? Quartiles are 4 parts. So that means that this first whisker should contain 25% of the data. This whisker should contain 25% of the data. And then this box represents the middle 50%. Okay, so the whiskers may vary in length, the boxes may vary in length. We'll look at a bunch of different examples throughout this lesson. Okay. And so what we need to do, a box and whisker plot essentially organizes the data in numerical order using medians. And so we use the median, which we call Q2. And then we take that and we use that median to divide the data into a lower half and an upper half. And then we'll find the median of each of those halves. So we call the median of the lower half the first quartile, and then the third quartile would be the upper half. Okay, we are going to come back to this idea of an outlier in a little bit, so I don't want to talk about it too soon. It won't really... you probably know what it is, but we'll talk about mathematically how we can figure that out in just a second. All right, so this first example, we are making a box and whisker plot that represents the ages of members on a backpacking expedition in the mountains. So the first thing you always have to do, since we're using 3 different medians, is organize all your data from your least value to your greatest value. And so as I'm looking here, it looks like my youngest person is 18. And then I have 2 22s. And then I've got a 24. And then I've got 1, 2, 3 25s. And then I've got 27, and then I've got 28, and then I've got 3 30s. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Awesome. All right, and so the first thing that you always need to do is put your data into Box, which is going to be Q2. So I'm going to find my median, starting at the edge, and then working my way in. Going in, going in, and so my median is going to be that. And so we'll look at two, if I was taking one out, your median, whenever you draw that line down the middle, you should have the same number of values to the right and the same number of values to your left. So if I were to take off that last 30-year-old, that 25 right here would have drawn a line right through that, so that I would have 5 values on the left and 5 values on the right. So if you have an even amount of data, you'll always kind of split it in half that way. If you have an odd amount of data, one of your values will kind of be cut off from that upper half, lower half. But since I do have these two middle values, they're the same. And so my median is just going to be 25. 25 plus 25 divided by 2. So I'm just going to write that there. So Q2 is going to be 25. And so now I've got this upper half of data and this upper half of data and this lower half of data. So now I'm going to find the medians of each of those halves, and that's going to be my lower quartile and the upper quartile. So as I work my way in here, 1, 2, so my Q1 is going to be the average of 22 and 24. And so that would be 23. And then up here, when I work my way in, Q3 would be the average of 28 and 30, which would be 29. Okay, so I want to go back up to the definitions here and show you how that applies here. And so here we say data along the number line using least value, greatest, quartiles of the data. The quartiles divide the data into 4 equal parts. And so if we look at what we did when we found the median and then the upper and lower quartile, each created a little subset of 3 data pieces. So whenever you're dividing your data up, you should have the exact same number of data values in each little subgroup. Okay. And so now what we're going to do is actually create your box and whisker plot. So we always need to start by making a number line. And then I'm going to title it what we are looking at. So this is ages of backpacking trip. Okay. And so we know that our lowest value is going to be 18. And my top value is going to be 30. Now you may have to decide on a specific interval. Since 18 to 30 is only 12 units. I would just go up by 1. But if your range is bigger, then you can choose to go like up by 5 or up by 10. We'll look at an example of that on the back side. You just have to make sure that your intervals are consistent. So I'm just going to count 18, 19, 20, 23, 24, 25, 26, 27, 28, 29, 30. So just to make it even, I'm going to go ahead and erase what I had originally put. And then go like that. Okay. All right. And so now what we're going to do, and you can label them all if you want, that's fine. I'm really only concerned you have to have your lower, your least value and your greatest value labeled, so essentially your 5 numbers, and then the 3 quartiles. And so what we're going to do now is go up to 23, so 18, 19, 20, 21, 22, 23, and that's where the box is going to start. The median is 25. So that's where the kind of in-between part of the box is going to be. And then Q3 is 29, so 26, 27, 28, 29. And then we'll connect those. And then we'll draw out our whiskers to the lowest and the least and the maximum. Okay, and so there's our box and whisker plot. So if you notice now, even though our data is arranged into three values here, 3, 3, and 3. Our boxes and whiskers are not the same length. So they have different ranges. And that just is because of the data that we have. And so this would kind of tell me the shorter the whisker, that means there's more of these values, they appear more often. So there's a lot more 29 to 30-year-olds than there are like 18 to 23-year-olds. Just in terms of kind of the lengths of those, the range of ages. That's what I meant to say. Sorry, the range of ages is smaller, not the number. Is smaller, not the number. The range of ages is smaller. And so same thing kind of here. If we focus on the middle percent, 50%, this would tell me that there's a greater range between this third set of data and the second little subset of data here. So there's the range is 3 years here and 2 years here. All right, and so now we're gonna make, just practice making another one. So this is the number of hours of television watched. I would think that in the last couple of weeks, these may be a little bit higher. All right, so I'm gonna go ahead and arrange everything first. From least to greatest. So I've got 0. No ones. I've got a 2. I've got a 3. I've got a 3. 4s, 1, 2, 5s, and 1, 6. So then I'll double check. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now I'm going to find my 5-number summary. So my median, if I work in, is going to be the average of 4 and 4. So this is just kind of a fluke. You're not always going to have the same value. So you might have to find the median sometimes. This just means Q2 is going to be 4. The median of our data set. Q1 is going to be the average of 2 and 3, which is going to be 2.5. And then Q3 is going to be the average of 5 and 5, which is 5. So again, you should always have the same, when you kind of sort everything out, you should have the same number of values in each little subgroup. So we've got 2 here, 2 here, 2 here, and 2 here. And so now I'm going to draw my number line. Make sure we title it. So this is the number. Hours of TV watched. And again, since this is a smaller range, the range is 6 minus 0. I'm just going to go by 1. So 0, 1, 2, 3, 4, 5, 6. Let's make it a little even. All right, so if Q1 then is 2.5, so 1, then is 2.5, so 1.5 would be right here. And I just ask that you really label that 5-number summary. So then Q2 is 4, so there's 3, 4 right here. And then Q3 is 5. And then make your whiskers from your least to your greatest. Okay. And so this one is a little bit more symmetrical than the other one. The middle boxes are closer to the same length. This whisker is a little bit longer than the other one, which means that the lower values have a greater range, but a little bit more symmetrical than the one up top. Okay. All right, and so Now what we are going to do is talk about just kind of interpreting a couple of different Box and Whisker plots. And this is where the idea of an outlier is going to come in. So we're going to kind of start and then we'll come back to the definition. So another measure of variation for a data set is called the inner quartile range, also known as the IQR. So the inner quartile range is always the difference between Q1 and Q3. The higher value minus the lower value, and it represents the range of the middle half of the data. So one of the things we never really defined this word. People know what it is. I feel like necessarily know what it is. I didn't necessarily take up space to do it. Remember, the range is always the highest value. Minus the lowest value. And so if we're looking at this Box and Whisker plot right here, it says this represents the lengths of songs played by a rock band at a concert. The song length is in seconds. So in terms of what this tells me, this tells me that the shortest song is 160 seconds. That tells me that the longest song is 300 seconds. And then here is the middle 50%. So the middle 50%, that is going to be our inner quartile range. So the range of the data would be 300 minus 160, which is 240 seconds. So, not 240 seconds. So what that tells me is that the difference between the longest song and the shortest song is 2 minutes and 20 seconds. So the longest song is 2 minutes and 20 seconds longer. The inner quartile range then, the IQR is going to be 280 minus 220. So that's the middle 50%. And so that is a range of 60 seconds. Okay, so essentially, the middle 50% of the songs are within a minute of each other. Okay, that's called the IQR. So the next question asks, are the data more spread out below Q1 or above Q3? And so that we're going to look at the length of the whisker. Because the longer the whisker, the higher the range, right? The range in the lower 25% is 60 seconds, right? 220 minus 180, whereas the range in the upper half is only 20 seconds. So we don't know how many songs, let's just say 20 songs, 20 divided by 4 would be 5. So if each little section represented 5 songs, the range of the first 5 songs is more than the range of the top 5 songs. So they're more spread out below Q1. And so then the last question that we're going to be asking is there an outlier? Okay, so if we go back to the front, an outlier is a data value that is significantly higher or lower than the rest. Okay, so there is a little equation that you use to help you determine if there is an outlier. And so what we do is you always take the IQR, the inner quartile range, times 1.5. And then we are either going to subtract from Q1 or add to Q3. to Q3.
And that is going to help us determine if any of the values are outliers. Okay, so if we go through that in this example,
Okay, so if we go
hopefully
through
it'll make
that
a
in
little
this
bit more
example,
sense.
hopefully it'll make a little bit more sense.
All right, and so if I am trying to find out if there's an outlier here, is there a song that is a lot longer or a lot shorter than the rest? We found that our IQR was 60 seconds. So the range of that middle percent was 60 seconds. So now I'm going to take 60 times 1.5 times 1.5, and I get 90 seconds. All right, so now I'm going to come back up to my box and whisker plot. All the data and all the songs are between 160 and 300 seconds. That's what this box and whisker plot means. So if I go to Q1, and it said subtract from that. So if I go 90 seconds shorter than this, so 220 minus 90 is 130. So if there is a song that's shorter than 130 seconds, that would be considered an outlier. But since my data stops at 160, that means that there's not an outlier. If I take 280 and go 90 out from that, I get to 370. Well, since there's not a song that's longer than 370 seconds, there's not an outlier on the high end, so that means that there is no outlier. Everything falls within kind of that similar range. Okay. All right, and so we are going to end this lesson guiding into what we will also look at tomorrow. And that is talking about the shape of distribution. And so when you're talking about the shapes of distribution, we're looking for a description that's either skewed to the left, symmetric, or skewed to the right. So if something is skewed to the left, then that means your left whisker is going to be longer. If it's symmetric, they're about the same length. The whiskers, not the boxes. And then if your data is skewed to the right, your right whisker is going to be longer. And so what that means is that if your data is skewed left, remember this represents your minimum value. And so if this whisker is longer, then that means that you have got this lower value that's pulling your data down. It's pulling your value that way. So if this is the case, then that means your mean is going to be smaller than your median, right? Because you've got this smaller value that's making your mean lower than it should be. This, if it's symmetric, means that your mean and your median will be very close to each other, not necessarily the same, but very close to each other. And then this right here, I want to look really quickly again at this example. And so when we found the mean wage was $9.65, that's because you've got that $16.50. That's in your calculation. So it's making your mean higher than most data values. And so if you're looking at this, that means most of our values are on the lower end, but you've got this high value that's making your mean bigger than it should be. All right, and so when we think about that in terms of the shapes of this distribution, test scores for our class and a friend's class. And so we can see kind of that our class looks like this, our friend's class looks like this, our friend's class looks like this. Our class would definitely be skewed left. Our left whisker is longer. our left
we've
whisker
got this
is
person
longer.
who scored like maybe a
We've got this
67-ish.
person who scored like maybe a 67-ish.
Made that happen. So
that
this mean would be
made
kind of
that
pulled
happen.
down
So this
by that average. So we kind of want to use the
down
median
by that
as
average. So
our
we kind
best
of want to use the
representation of the
median
data there.
as our best
Whereas in our
representation
friends
of the data
class,
there.
the whiskers look like
Whereas
they're
in
about
our
the same
friends
length,
class,
right? That's
the
gonna be
whiskers
10,
look like
that's
they're
gonna be
about the
10.
same
So these
length,
are actually
right? That's
exactly
gonna
the
be
same
10,
length.
that's going
So
to be
this
10,
would
so
be
these are
exactly
actually
symmetric.
exactly the same length. So this would be
Okay.
exactly symmetric.
So then in terms of which test scores are more
So then in terms of
out,
which test scores
we
are
want to
more
think about if I were
spread
to actually
out,
list those out, how
we
would
want
that
to think
look?
about if I were to
And so
actually
we
list
can
those out,
kind of
how
see
would that
here
look?
if
And so we can
75%,
kind of see here if 75%,
right? So I've got these three out of the four
right?
pieces.
So I've
So
got
75% of the class
pieces.
score between
So
an 85 and a
75%
100
of the
on it.
class score between
And then
an
I've got
85
these
and a 100 on it.
the bottom 25%
And then I've got these
down here,
the bottom
as opposed to this
25%
class
down
where
here.
it looks like
As opposed
all
to
of
this
these
class where
pieces
it
are
looks
exactly
like,
the same
all of these
range. 10
pieces
10,
are exactly
10,
the
and 10.
same range.
So that definitely
10,
means
10,
that our
10,
friends
10.
class
So that
is more
definitely
spread
means
out
that our friends class is more spread out
because both the range
because
and
both
IQ
the
are
range
bigger.
and IQ
So that means our data is going
bigger.
to be more spread out there.
So that means our
Okay.
data is going to be more spread out there.
All right, so your homework tonight is the 10.2
All right,
worksheet
so your
posted on
homework
Canvas.
tonight is
Just
the
hop on
10.2
Canvas
worksheet
Conference
posted on
and
Canvas.
questions.
Just